Hello everyone, welcome to this week 3 tutorial. Still now, only two people have joined, so let us wait for a few minutes so that other people join, and then I will start in few minutes. Okay, in this meantime, whoever have joined, please share your mail ID with me. I will share the course materials which I am showing you in the live sessions, as well as some extra materials which will help you in a link. There you will if I will add you guys so that you can access that link, and for that I need your email id, so one by one you can write the email ids of yours, with which you can connect the Google Drive. In the chat box I will give the permission to you to look at these materials. Those who want to access the materials of these live sessions and some extra materials which I'm going to upload in a link, please share your mail id in the chat box. Write that I will give permission to you to use the to see those materials. See those materials, so please write the mail ids whoever want to access those. Godhuli, I have given I have given the access to you.
Yes, ma'am, I received.
Yes. And please write the right email ID. Otherwise, it will not be. You will not receive. And Priyan is writing some mail ID, but it is starting with capital S. Is this start the mail ID with the capital S or it is small s? Just correct it. Maybe it will be small s. I don't know. Many people has already requested me. I have given them already beforehand, and those who have not till now, then they please write the mail ID. I'll give the access of the portal of the Google folder where you can check the materials. Okay, maybe whoever will join and whoever want to access the materials, they please do write their mail ID in the chat box. I'll give the permission and add them in the Google folder link. And now I'll start our today's session. But as I used to tell every session that the a brief introduction of this live sessions, that we are here for studying nuclear astrophysics, and this is week 3. And there is if anyone miss the live session, then they can see it after, they can watch it after, whenever they find it comfortable. There it will be uploaded in the YouTube, and the YouTube link, let me share, because many sometimes mail me that to for this.
YouTube link is already shared in the NPTEL
Yes,
website.
yes. That is already shared with the SAM portal and NPTEL. But I used to get sometimes mail that please share. Can you please share the YouTube link and all those? So on regular basis, I keep the link also in the chat box. Okay. But yes, if you find any questions, then do write into the chat box or ask a question portal of SWAM, and we are always there to help you guys, and this live session will always be helpful for the examination. And today is 18 March, I think. Today is the last day, or I forgot actually the last day to registration, but maybe near it is very soon, 1 or 2 days, or maybe today, or within the next week. Now now we will discuss about uh, today's thing, that what we are going to cover today, and what we are going to cover today, and what you have already learned from in week 3, and what are the key concepts that you are going to learn today. Okay, so let's start. I hope the slides are visible to all of you, and I am audible to all of you. Anytime if you find any problem, then please let me know by writing in the chat box or by unmuting yourself. And don't unmute yourself while somebody is speaking, or I am speaking. Okay. So, okay, let's start. So this is the week 3. We are going to discuss about that, and in week 3 the covered topics were reaction rate and neutron induced reactions, gamma induced reactions, and inverse reactions again, continuation of that, and mean lifetime of a nuclei, and time dependence, abundance, evolution. So these were the topics that were covered, and for this week particularly, you guys have enough mathematical background for all the reaction rate, neutron the reactions, inverse reaction, to calculate mean lifetime and all those things. So I don't need to explicitly describe the mathematical background for this topic, but there are already many topics for which the mathematical background was not rigorously given in the lectures that we were covering. And somebody used to ask many question in the ask you question portal, or sometimes by writing mail, that please cover these topics. So I try to cover those topics also. And so let us now see that what are the key concepts that we are going to learn today. We are first thing is, I will give a short recap of all the topics, not all the topics, but with three topics, like what is the cross section, what we got, the binding energy, mean lifetime, mass fraction, binding energy fraction, all those things. Then I will go to the liquid drop model, shell model, and spin parity calculation using cell model, because this is very needful for the course. And I am hoping that you are going to get some question from cell model, and for the final examination. And you obviously it was told into the lecture also, that you should revisit these topics once, the liquid drum model, cell model, and all those things, and the basic of nuclear physics also. So for that purpose, I asked you guys on the previous day that should we revisit this, and people supported for revisit this once again. So I will discuss about this first today. Then I will go to some then I will go to the question answer solution part. And in between, I will also discuss about the photo disintegration. That is already, this term is already introduced in the course in week 3 material, and astrophysical S factor. And then modeling of a star, I have given that in the last, as a last topic, because I have promised you guys that I will talk about modeling of a star, but it will not be there in your examination for sure. For that reason, I am thinking right now that maybe we don't need to uh, do the rigorous mathematical background. We don't need to develop the rigorous mathematical background for this modeling of a star. But as it was already, it was introduced into the course, and this is a good thing to learn, and it will be something interesting which will show you the mathematics behind developing some astrophysical model. For that reason, I wanted to cover it. So I am thinking that maybe there are too many topics for today to cover, so I'll not be able to cover the modeling of a star today, but certainly I will describe about modeling of a star in next class. And last but not the least, I'll also discuss today about quantum tunneling, because some of people have those who are maybe in a PSC first year, second year, or plus 2 level, they have asked for the quantum tunneling thing, that please go through please to discuss that part also. So I will discuss that today. So these are the main things that I am going to cover today, and it is going to, I think, I hope that it will be a very interesting session and helpful session for all of you. So now let me go to the writing pad and stop the presentation, because I will do first short recap, and then go to the liquid drum model, cell model, and there will be a lot of discussion and lot of background development with the with some sort of mathematics and some sort of theoretical part. Then I'll go to the problem solution. And let me stop the sharing of slides and go to that. All right, I think you guys can see the writing pad. And now let me start that. First, I will start with the cross section. You guys have already learned about cross section and a lot of heard about these a lot of time by now. And so this is a short revisit of that, because I am going to we are going to solve some questions today on this on the concept of cross section, so it will be helpful for you. So the cross section, first topic is cross section. So cross section is defined as sigma already, and this is cross section for reaction. It is, and that is equal to number reactions. Let me write it. I'm going to give you direct, like not a definition only, but direct the definition in terms of mathematics, such that you can it becomes easier for you to solve the questions. Okay. So the sigma cross section for reaction is equal to number reactions per nucleons per second by number incident number of reactions and number of incident particles of, I am not writing the adverbs, and then per centimeter square per second. So this is the cross section, that is the number reaction per nucleus per second in the numerator, and in the denominator the number of incident particles per centimeter square per second. So you can clearly see that this has a unit of centimeter square. Which means that we are actually seeing that how much reactions is happening with respect to the number of incidenting particles on a particular area, and we represent it in terms of area. Okay. So this is the first thing. And now, what was the definition? Sigma was pi rp plus rt whole square. This was for classically, where rp is for pi r this is nothing but the rp plus rt, that is the projectile, the radius of the projectile and the target. And we all know the area is equal to pi r square, and this is projectile plus target, both of them radius, that is the sum of them, and then the square. And we are just doing the area of a circle, that whatever we find, that is it. So this is a cross section for reaction. But we exactly don't know what is the rp and rt. So how will we know about the rp and rt? For that, we need to know about the nuclear size, so that we can easily calculate rp and rt, and by calculating them, we can calculate the cross section. So for that, we need to learn about the we need to visit once about the nuclear size, and I will go that. And by this nuclear size itself, slowly we will enter to the nuclear models, like liquid drop models and cell model. So make the connection in your head while I am talking about these things, because everything is connected. All right. So this is the classical part. And what was this sigma for the quantum mechanical case? It was pi lambda square, where lambda is the Broglie wavelength physically, but the expression here, it will be lambda is equal to mp plus me mt sorry mp plus mt by mt by h root over of 2 mpel. and this is already been introduced in your course, and there are a lot of discussion in the lecture already, so I will not go to these details. And mostly you can imagine that you are going to get questions from classical cross section calculation, not from the quantum mechanical part. So the now I will end up this revision by asking the question that how RP and RT will vary with A. Okay, and for that and this is that is why I was talking about the that RP and RT calculation to calculate the cross section, and to while I will discuss about the RP and RT, then we'll discuss about the nuclear size. But before that, let me go through all the revision part, then I will address this question again. So this is our first question that we'll address while the division is done. Okay, so the next topic, next thing what was covered in the lecture was non-resonant reaction per particle pair, and that was sigma v, and this is nothing but the average, sorry, average of the cross section times velocity. Okay, and this has a particular big expression which we will learn today also, and it has already been introduced, but there was a question in your assignment 3 which was related to this, and today we are going to discuss and learn that how to tackle and solve this kind of question, because this is a very important topic in this course, and you can get a question related to this for the final examination. So what through a question I'll discuss the details of this mathematical calculation, and from where you can get the detailed mathematical development, from which book, the book and page number I will mention while I will solve the question. But you please try, when I will do this problem, please try to learn this, because this is a very important question, and you will get the that you will get the idea that how to solve this type of question. So now I am not I am giving just a division where I am writing that what you have learned till now in the week 3, but not writing any expression for this. Okay, now the number 3 thing, third part you learned is number density, which was denoted with Ni, and it can be written in terms as rho Na by Mi, where rho is equal to matter density, Na is equal to Avogadro number, Xi is equal to mass fraction, Mi is equal to atom. Mi is equal to AMU, atomic mass unit, mass of the nucleus. Okay, so this is also been discussed in the course, in the lectures in detail, so I will not discuss about how to derive this in this live session. Rather, these are the key points that you need to remember. First I discussed about cross section, then I discussed that is classical and quantum, and this one is much more important for this at this moment. Then the non-resonant reaction per particle pair, sigma v, that is also very important, and we'll discuss about it lot today in later part. and then the number density that you have already learned in the course, and this is how it is defined. Now mean lifetime. Fourth is mean lifetime, which is equal to 1 by ni, that is a number density, into sigma v. Now I hope you can understand literally that how and little bit that how mean lifetime we are getting, and for that we need sigma v, the average of the cross section times velocity, and that will help us to calculate the mean lifetime, which is a very important thing to know, to get the elemental abundance, to get the curves, binding energy curves, elemental abundance curve, and all those things. So we know that in case of nuclear thing or nucleus anything, we the lifetime, mean lifetime or half lifetime, that those are very important parameter, and by just calculating the cross section and the velocity times cross section, average of the cross section time velocity, and we will also get to know about the number density. If we have just these three parameters, then we will be easily get to know about the mean lifetime without even interacting or doing any kind of direct direct contact with that. So that's why we can calculate the mean lifetime and what is happening inside a star, though it is so far distance from us. So these are very important aspects. These are the aspects that we want to address in this nuclear astrophysics course. That's why I think that within with the time, as the classes are going on, you are getting the vibes that how nuclear physics and astrophysics are related to each other, how nuclear physics has developed astrophysics, and astrophysics has helped to develop nuclear physics. So this is a very common question. I used to get that what is nuclear astrophysics exactly is. So I think now it is clear for all of them whoever is attending this course and attending the live sessions and listening to the watching the lectures carefully. All right, so now I'll go to the binding energy. It is already been discussed in the previous class, and I have discussed about it quite a lot, because I also shown you guys the change of the units, how to transfer from AMU to that from joule, kilo electron volt, mega electron volt, AMU, all those things, and how to calculate binding energy. I have given the example also. So please go through that, and please record us practice that for your examination, and to get to and to be easy with these things. Okay. I'll not go to the details of binding energy today, because I have already discussed it. And the bind now the thing come is that some new terms, that is binding fraction, that is binding energy per nucleon. It is denoted with a B. You can write it as sorry, binding energy per nucleon. Now the next thing is, now next term is mass defect. This is already known to you, but maybe you are not aware that it is termed as mass defect. So mass defect is denoted, if I denote it as del m dash, then del m dash equal to m a z minus a, which is equal to difference between the measured atomic mass in U and mass number A. And you guys know what is MAZ and AAZ, all those terms by now. So this is this is a thing of mass defect, and now it come about packing fraction. Packing fraction is nothing but the mass defect per nucleon. That is equal to del m dash by A, which can be written as MAZ minus A by A equal to MAZ by A minus 1 MAZ by uh, this is equal to F A MAZ minus A. Finally, we get MAZ is equal to A into F plus 1. That means if we know the packing fraction, then we can easily get that what is the mass of the sum of the A and Z. Okay, so that's why it is important. Otherwise, I mean, why to discuss about packing fraction? What does why do we need that? So this is the reason. If we know the packing fraction, we know MAZ. Now, this was a recap or revision of previous lectures in week 3, where it was discussed about cross section, and I have discussed about cross section. Then now non-resonant reaction particle pair, sigma average of sigma v, then the number density, then the mean lifetime, then the binding energy, binding fraction, mass defect, and packing fraction. You may think that this kind of a little bit calculative question, short numerical type question you may get. And remember, for this type of question, the change in or the transformation in the units are very important, because mostly the students do mistake in case of calculating or transferring into the units. Sometimes it's told as kV, sometimes MeV, sometimes AMU, sometimes U, whatever. So for that reason, do the calculation very carefully for calculating these things. Okay. So now I will go to the new topic. First thing, that what the question I have addressed beforehand, that how RP and RT will vary with A. How will you calculate? For that, we will visit to the nuclear size. Nuclear size. Now these are the new topics for today. One, nuclear size. As we know that nuclear size, whatever we used to consider primarily, that is a sphere. If we consider that nucleus is a sphere like blob, then we can write that volume of nucleus is nothing but 4 by 3 pi r cube, where r is radius of the nucleus. Point, assuming nucleus is spherical, though it is not true, it is not spherical exactly, obviously not. This is a classical concept, but to calculate the for the primary understanding, we used to consider it as the spherical blob, and that is, from that itself we get the relation between r, that is the radius of the nucleus, and the mass number A. And that is well enough, that has been verified with the experiment also, but this has not this need not to be correct, that the classical analogy is equivalent with the quantum analogy. That is not true, but in this case we can consider that this is a well enough assumption, and we can go with this. And for this course, it is enough to calculate r and the relation between r and A in this way. All right. So what if this is for volume is 4 by 3 pi r cube, and it is directly related to the mass number of the nucleus. Mass number, then we can write that 4 by 3 pi r cube is proportional with A. That is the radius of the nucleus, that has been already mentioned, and this is the mass number. Then we can write it as r cube is proportional to A. I am writing with the proportionality constant, because I don't know what other constants are there and what need to be there to exactly vary with that. But at last we'll get the relation, what is exactly, how it is exactly varying, but I'll not calculate the constants down here. Okay. So r cube is proportional to a, then r is becomes some constant r0 a to the power one third. So where r0 is equal to 1.1 to 1.15, in between that into 10, sorry, into 10 to the power minus 15 meter, or 1.1 into 1.5, in between, something like that. Sometimes it considers 1.1, or sometimes it is 1.5. That depends upon few things. But when you will get something like this in question, mostly the r0 value will be provided to you. If it is not provided, you can consider 1.1 or 1.5 into 10 to the minus 15. That does not matter. Centimeter, or 1.1 to 1.5 femtometer, we can write it like that. Okay, so now we know the relation between r radius and the mass number, that is nothing by r equal to r0 a to the power one third, and this is a very important relation. R0 I have already written what are the r0. Okay, and again I am telling that whoever has joined later, that if anybody wants to get these notes, whatever I am writing in live session, or whatever material I am using or I will use, or maybe I found interesting for you guys, that I will upload in my Google Drive folder that is already shared with you with Swam portal. But you need access for that to see that. And for that you need to send request. Either you need to send request, or you can write the mail ID to me, and I will give you the access if you want to get these materials. Okay, so you can write it now in the chat box, or you can write directly a mail to me, or you can directly request me by with the SAM portal, or in the mail, whatever fits for you. I'll give you the permission to see these materials. Okay, so yes, you can write the
Excuse me, ma'am.
yes.
Ma'am, I have a doubt. What does R naught means, ma'am? R naught means initial radius of a nucleus.
Yes, that is the constant term, like whatever that 4 by 3 pi and some constant, another constant it will come. And you can consider that that if a is equal to 1, like mass 1, then what it is, r is equal to r0, right? That means the smallest possible nuclei which can be considered, that is equal to r0. So this
Okay,
is
ma'am.
nothing but that. Do you understand?
Okay. Ah, yes, ma'am. Thank you.
Okay, so r equal to r0 it will one third. Okay, so this is the size of that is how we calculate the nuclear size, and the relation between r and a, and how this will help because we easily know the from the periodic table, we easily know the mass number of any nuclear. And if we know the mass number of nucleus, then and we know r0 now, then we can easily calculate the radius by this way. So it is very helpful, and once we know the r, then we can calculate the cross section also, because we know the p, and this is rp and rt, that is already given to you. That is not given to you, and you can calculate now by using r0 to the power one third, and you will get the sigma also, that is a cross section. So mass number is the main thing that is already provided with the periodic table, and once you know the mass number, you can calculate r. Once you calculate the r, you can calculate the cross section. Once you calculate the cross section, if you know the velocity, you can calculate the average of the cross section times velocity. And once you know the number density, you can calculate the mean lifetime also. So I am telling these things again and again because you are going to get questions from the with these relations. These are very important relations, and I am connecting between them, that how if you know the mass number, then by connecting one by another, you can reach to the mean lifetime and all those things. So I hope this is clear to you, that these relations you need to make connection in your head, that how we are going to get one parameter from another, just by knowing the mass number and few other things. Okay, all right. So this was the first thing that I want to discuss today. Now the second thing is that liquid drum model, and as I have just ended up with that R equal to R0 to the 1/3, that is related with the nuclear size. So this is the perfect stage to discuss about liquid drum model now, because what are these? We are talking about liquid drum model, cell model. These are nothing but we are trying to model our nucleus to know that how exactly the nucleus is, what is the true nature, to behavior, to structure of it. And for that we obviously need to do some assumptions, and with the assumptions we want to infer as much as possible to get the exact idea of the nucleus. And for that various kind of modeling was done from the for past 100 decades, for 10 decades. And the first model which was addressed is liquid drum model. And why it is called liquid drum model? Because here we consider nucleus as a drop of liquid. It behavior, if we consider that obviously we know that liquid drop is also a sphere like matter, spherical thing, but it is not so defined like a classical blob spherical ball. So if we consider liquid drop kind of thing, then we can infer some properties of the nucleus. But if you see that, if you want to address some more properties of nucleus like the magic numbers and all those, then you will observe that liquid drop model is not a very exact model. That's why we need to shift to some other model, and that's how we get to cell model. Then cell model is able to get give the idea that how the magic numbers are so stable, magic number nuclei are so stable. But there was also some problem. Then now we also discuss about Fermi gas model, but this is not a right place to talk about Fermi gas model and all those. And mainly it will be helpful and useful to discuss about liquid drum model and cell model at this moment. So first let us discuss about liquid drum model, that what was told in this model. In this model, all this modeling, what we calculate, we just calculate the binding energy, nothing but the binding energy. Once we have the clear idea of binding energy and the ground states, then we will be able to get the real essence of nucleus. And for that, in case of liquid drum model, we write binding energy. I am just writing as Be. That means binding energy. What is this in case of liquid drum model? And I will also discuss that how we reach there. This is written as AVA minus AS a to the power 2/3. I am giving some gap because I will write something here. Minus AC Z into Z minus 1 by a to the power 1/3 minus a minus 2z square by a, again some gap, plus minus delta a to the power 3/4. This is the formula. This is the formula that of binding energy in case of liquid drum model. Now what are these terms and how we get this? First term is volume energy term. Second term is surface energy term. Third term is Coulomb energy term. Fourth term is asymmetry energy term. And the fifth thing is the delta by a to the power 3/4. This is a parity energy term. there is one important thing, that is parity in case of nucleus. That is just, what is parity? Parity is just the headness of the nucleus. That if you take a mirror image of the nucleus, then what do you find? If it is symmetric, if it is just a mirror image of that, then it is same parity. And if it is in the same direction, then it is even parity. And if it is in different opposite direction, with the real image and the mirror image, then it will be odd parity. So there are two kind of parity. So you don't need to go to the details of parity at this moment, but there is a parity term, and even you don't need to worry about this parity term in the binding energy for the liquid drop model also, because this is quite a high level this is been discussed in some some like more upper graded course. For this, at this moment we don't need to worry about the parity as much, but yes, this is the parity energy term. Now how we get this? First thing is volume. First I told about the volume energy term. That means that is related to volume. And I have already told that nuclear size volume is directly related with the mass number. So here we also can write that in terms of mass number. That's what I have written in case of this formula also, A V into A. But volume energy, why volume energy? If we consider liquid draw something like this is a drop, like, but like some sort of spherical only, spherical shape only, because we know the most stable form of a liquid drop is spherical. So we can consider that for this volume, that nucleus wants to stay if it wants to stay like a liquid drop, then it should spends the main energy it is coming to make it stable is the volume energy, which is making it the spherical like nature. And that's why it is called as volume energy. And we can directly we can calculate it like this manner. Like we know that r is proportional to a to the power one third. That means r cube is proportional to a. That means we can write 4 by 3 pi r cube into some other constant, maybe we don't know, and that is equal to a. So what at last what we get, that volume, this is the volume, is directly equal to some constant that I am writing as ab, because volume constant, and a. This is the mass number. So that is how we are getting the volume energy term. Now the second thing is surface energy term. And surface energy, what it is? 4 pi r square, nothing but this. And 4 pi r square r, we already know it varies like this. So we'll get it some constant again, that is surface constant. That's why it is as, and it is equal to 2/3. And why we are worrying about surface now? Let's come to that point. If it is a sphere, spherical like thing, then the volume is trying to bind it and make it stable. But surface, if you consider a surface here at this point, then it will, the surface this point, and there are like this surface, then what they want to give some outward direction force which will try to unstable it. And that is why the surface energy comes into the role, that it will try to reduce the total volume energy. That's why we are giving the minus sign here, and this is how it is varying. So now we got the energy as AVA minus AS a to the power 2/3. Like this manner, the Coulomb energy term, that will also try to reduce, and as the nuclei like plus minus all those are there. Plus wants to repulse, minus there will be no minus, sorry. The plus charges, protons will try to repulse, and for that there will be some amount of energy which will be lost again from the total energy of volume due to this Coulombic repulsion, and that is why we are writing this Coulombic energy term, and that will be varying with AC Z into Z minus 1 by A to the power 1/3. And how we reach to this point? We reach to this point because the energy for this is the third part, Coulomb energy. Now in a nucleus of Z atomic number, we have ZC2 such configuration where the Coulombic repulsion is possible. So we have Z into Z minus 1 by 2. If you calculate this, then you will get this number of configuration, this number of times when the Coulombic repulsion energy will be filled, will be there. So for these times, some constant, this is the number of times, this is the constant, it will be varying with 1 by r, obviously, because we know that Coulombic energy, if it is Coulombic force, it is 1 by r square, and if it is energy, then 1 by r, it just vary with 1 by r. That's why we can write, if we write this constant again as AC, because it is Coulombic constant, then Z into Z minus 1, sorry, Z into Z minus 1 by 2 into e to the power 1/3. That is how we get this term. Okay. So this is the Coulombic energy term. Now the asymmetry energy term. Asymmetry is counting for, like, as I was telling, that though it is a liquid drop model and liquid and it's tried to be in spherical shape, but it is not really spherical all the time. That's why we consider the asymmetry term, and asymmetry energy is coming because in the stability, if you see the nuclear stability graph, nz graph, then you will see, if you plot n versus z, that is, it is called the stability curve. By the way, this is an important thing to note, there is something called stability curve of nucleus. For the hydrogen, helium, lithium, beryllium, boron, these things, like the lower Z nucleuses, they actually have equal number of protons and with the equal number of protons and neutrons. But as we will go for higher or heavier nucleus, you will see that n is not equal to Z. Rather, n starts to n, or that is a neutron, starts to increase in number than the protons, and that is what is described in the stability curve. In reality, I'm extremely sorry, some light has gone. I don't know if you can see me or not, but I hope you cannot see me, but because of such very unnatural and sudden power cut, I don't know why this is happening in institute, but yes, let me continue with the discussion, and by some time I hope the power cut is will be fixed. So yes, 1 minute. Okay, whatever you can see or not see, I don't know. Let me continue that. Okay, whatever you can see or not see, I let me continue that. Whatever we are discussing, that this is the stability curve where n versus z is plot, and If we plot that, then what should we get is this straight line, but we will not get this. Rather, it will be like something like this. As it will move towards heavier nuclei, the number of neutron will start to increase than the number of protons. And this is the and this is the and now we are calculating the asymmetry term. This will be, then you can understand that asymmetry term will arise from the difference between n and z, that is n minus z, because n number is greater than the z and it will some sort of dependent upon n minus z. So if you talk about asymmetry energy, then it will be directly proportional with n minus z square, and it can be again written as a n minus z square by a n, because it is denoted as a n, just asymmetry energy term. And asymmetry energy term, and it is a n is again can written as a minus z, then we will get a minus 2z squared by a. That is how we get the asymmetry energy term. And now the pairing energy, pairing energy term, that we don't need to worry about. We get pairing energy term like binding energy P, that is equal to plus delta by a to the power 3/4 is equal to 33.35 MeV for even. It is equal to 0 for even odd nuclei, and is equal to minus delta by a to the power 3/4 equal to minus 33.35 MeV for odd nuclei. Okay, so finally this is the liquid drum model. We have got all the term, and this is the final relation that you will get. I am not writing that again and again, because that I have already written with the terms, and you need to remember this. And why when we got the binding energy, then by doing, okay, now I think you can see again. 1 minute. Extremely sorry for the disturbance. Yes, let us continue with whatever we are doing. That binding energy, now we got the binding energy. Finally we have discussed all the terms: volume energy term, surface energy term, Coulomb energy term, asymmetry energy term, and binding energy parity term, and finally reach to the final relation. That is very important, and this is what is liquid drum model. And by calculating that dmdz now equal to 0, you can get the stability condition and the parabolic, the beta decay, beta plus decay, beta minus decay, all those things, but those are not needed to be done here. So I am just discussing about the relation and what you are going to get, and what is the main funda of the liquid drum model. So there, this is a liquid drum model. It was well enough model, but there was one problem, that it is a liquid drum model. The disadvantage of it is liquid drum model is unable to describe stability of magic numbers. What are the magic numbers? Magic numbers are those nucleus in the binding energy curve which has higher stability, and we need to describe why these have higher stability, and liquid drum model was unable to describe that. For that we needed some other model, and this is what we call cell model, because we consider now the nucleus as a like what we call what we consider for the electrons, that electrons are spread in cell manner, 1s2 1s, whatever we have learned in the plus 2 level. That will same thing here will be addressed, that the nucleus is now a cell. It is behaving like a cell and it has some fine structures. So if we consider that, then we are able to describe the stability of the magic numbers. Now let me write that what are the magic numbers. You should to solve the, this is very important actually. Let me tell that this is very important, because you are going to get, you already have got a problem in the assignment 3 regarding this, that how to calculate the ground state of using the cell model of a nucleus. And for that the cell model is important, and you need to remember few things to solve those kind of questions. So magic numbers is one of them. That's what you need to remember. The magic numbers are 2, 8, 20, 50, 82, 126. These have high stability. Now I'll show you that what is this in case of these, what is actually been done. Just like the nucleus thing, you can see that these are the cell. If I this is 1s half, and you need to remember this thing you need to remember, that how the distribution of the cells are there. 1p 3/2, 1p half, and this is the way that it will go from down to up. Okay, then 1d 5/2, 2s half, 1d 3/2, and now the fifth stage, that is 1f 7/2, 1p 3/2, 1f 5/2, 2f 2f 2f, it will be 7/2, 5/2, 2p, sorry, p will be half, so 2p half, and 1g 9/2. Okay, so these are the things, and this is equivalent to 2 nuclei. That is, after that it will be, how we are going to calculate the 2, because this is the j number. J is this 1 minute, I am writing as 1 is half, this half is j, this s is l. Now a is equal to 0, p is equal to 1, d equal to 2, f equal to 3, g equal to 4, and so on. And these are the l values, and j values equal to l plus half to l minus half. That is how we calculate j. Then we have, once we have this idea, this is the n number of cell number, main number, that is the primary number. Then we have l corresponding to this spdf, g, all those, and then the j number, that is written in half, 3/2, 5/2, that manner. Okay, this, so this is the lj, all those things, and you need to remember this again to solve those questions. So now we once we know that j, then 2j plus 1 number of nucleons are there in a cell. Okay, so number, so if you have j is equal to half, then you have 2 into half plus 1, that is 2 number of nucleons they are in the cell. If j is equal to 3/2, then sorry, then 2 into 3/2 plus 1, that is equal to 4. j equal to 5 by 2, then 2 into 5 by 2 plus 1 equal to 6. Okay, it will go like that manner. Then if we calculate the number of nucleons in every cell, then we'll get 2, then 4, then 6. Again this is 6, 2, 4, 8, 4, 6, 2, 10. That means this is equal to 2. That is a magic number. This is equal to, sorry, this will be 2. This is equal to 6. If we now if we plus them, add them, 6 plus 2, then what we will get? That is 8, another magic number. This is equal to 12. If we add 12 plus 8, then what we will get? That is another magic number, 20. This is equal to 30. If we add 20 plus 30, then what we will get? That is equal to 50. That is another magic number. That's why there are the gaps in between where the magic where the numbers are it is ending in such a manner that if you add this number of nucleons with the previous number of nucleons, then you will get the magic number back. That is where the highest stability is. Okay, and you need to remember this model to solve the ground state, any ground state problem, and 100 with 100% surety. There is nothing to worry about this type of question, and you can calculate this. And how will you calculate now the ground state calculation? There are few possibility. Either nucleus will be such that equal number of proton and neutron will be there, or equal number of neutron and proton, and number of proton is even and number of neutron is also even number. It may be possible that neutron number or proton number is even and odd or even, vice versa. Or it is even possible that even odd number of neutron and odd number of protons are there. So for these three different cases, you will get three different. You have to follow three different technique to get the ground state. First, which is the most important, which is the even odd condition. That is the mostly like you can think that most of them, whichever will be asked in the examination or assignment, those will be even odd types, because this is naturally given in the examination, or whatsoever, that does not matter. But I will discuss all these three conditions: even n, odd j, or odd even, odd n, even j. Then how will calculate? Let me take an example. First is 1708. By the way, this will be very helpful for whoever is planning for writing GATE examination, IT JAM examination, because this type of question is very common in GATE and NET. So the 1708, that means we have proton number of 8 and neutron number of 17 minus 8, that is equal to 9. This is even, this is odd. First, we need to find out which one is better, 8 or 9. 9 is greater. So we will now carry forward the further problem with the highest number thing. Highest number is neutron here, that is 9. Okay. So how will we calculate now? For that we need to first write the sequence, like in up to, if we go up to which cell, so that we get 9 nucleons. So 1 is half, at there will be 2 nucleons. Then 1p 3 by 2, there are 4 nucleons. Then 1p half, 2 nucleons. Then 1d 5 by 2, there are 6 places that 6 nucleons can stay there, but we have only 1 left, because 2 plus 4 is equal to 6, 6 plus 2 is equal to 8, 8 plus 1 is equal to 9. That means there are only 1 nucleons left, which will be there in 1d 5 by 2. And this sequence is nothing but 1 is half, 1 p, like this manner, 1 is half, 1 p 3 by 2, 1 p half, down to up. Okay, so we can write this now in this sequence. If we get this, then we can now understand that what the last nuclei is in the 1d 5 by 2 cell. Now we will calculate ground state. Here 1d 5 by 2 means J is equal to 5 by 2, L is equal to 2 because it is D, SPD 0, 1, 2. So the formula for ground state will be, for this case, J to the power minus 1 whole to the power L. J means 5 by 2. Now minus 1 whole square, that means minus 1 whole square, that means plus. That means it is 5 by 2 plus. If it was minus 1 whole to the power 1, that means it is minus. Okay. So the ground state is finally 5 by 2 plus for this 8017. Now I will go to the next condition, that is the odd nuclei. Odd N, odd Z, odd Z on N. Does not matter. So for example, let us understand with example. 14N7. We have neutron number 7, proton number 7. Now we will write the sequence. 1 is half, 2, 1p 3 by 2, 4, 1p half, 1, and 4, 5, 6, 7. Okay. Now for this case, we need to calculate first the total angular momentum. These JL are nothing but the angular momentum. You can get the analogy with the atomic model of atomic precision model, the precision model, those we vector model, atomic vector model. This is like that type of thing. Okay, like J is the total angular momentum, L is the orbital angular momentum, S is the spin angular momentum, then J is equal to L plus S. This is just like that. If anybody wants to get this concept again, then please visit to the atomic vector model, vector atom model, to to the remember all those, to get the vibes again of the angular momentums, what was there in the spin, orbital, and total. I will not go into the atom level again because this is already too much heavy course to carry forward, and if I start to discuss about the atomic level, then it will take much longer time and we will not be able to solve the question. So total angular momentum is it will be Jp for proton, Jn for neutron. Here both is 7 7, so both will be these. Then Lp plus Ln. If this is equal to even, let me write it here. If this is equal to even, then what we will calculate? Then we will calculate J is equal to Jp minus Jn. Minus means this is the modulus of Jp minus Jn. If it is odd, then Jp plus Jn. That will decide the ground state. And the parity, the plus or minus, that will be decided as minus 1 whole to the power Lp cross minus 1 whole to the power Ln. For this 7 and 14, we have last cell in 1p half 1. That means Jp is equal to half, Jn is equal to half, p is equal to 1, and LP is equal to 1, Ln is equal to 1. So J total angular momentum is equal to half plus half plus 1 plus 1, that is equal to 3, that is equal to odd. So the ground state will be, now for odd case, Jp plus Jn. That means half plus half equal to 1. 1 and the minus 1 in to the power 1 cross minus 1 to the power 1, that is equal to minus 1 equal to plus, that means 1 plus. That will be the ground state in case of 7 and 14. Please go to these formulas and whatever manner I am doing, try to circulate these in your head and realize that what I am doing by your own hand. Then you will be get the essence, you will get the essence that how to calculate it. First case was even odd, second case was odd, and most easy case is, I'm writing here just to complete it, the third number is even, that is j is equal to 0 plus, this is 0 plus, that is it, easy. If you get a even condition of even number of n and even number of j, then j equal to 0 plus. Okay, so this is the cell model, and I am able to complete all the all the things that I want to address from the nuclear physics. And these are the long topics that one should remembered for this course and useful for competitive exam as well as these course in final examination, as well as to get your for whoever is in BSc MSc, all those courses. So finally, whatever we have discussed a lot of things for past 1.1 hour and 15 minutes, and now I will go to the question direct to the questions. But let me revisit what we have done. First, we have some revision of or the recap of the week 3. Get the we see the cross section. We see the cross section how it is for the what it is for the classical and quantum mechanical, and then non-resonant reaction part, particle pair, then number density, then mean lifetime, binding energy, mass defect, packing fraction, how they are related with each other, how the new topics which I have covered in this discussion section newly, those are first of all nuclear size, how we can relate radius with the a, that is the mass number. Then I reached to the equation, and then finally we started the nuclear modeling, that is the liquid drum model, how the binding energy is varying, how we are getting each and every term, then the disadvantage of liquid drum model, and we are moving to the cell model. Let me write the heading shell model. Then we got after then we discussed about cell model for even odd even configuration, and how to calculate the ground state. Now we know many things, we have discussed many things. I will go to the problems. So our first problem. Our first problem is, classically the geometrical cross section for the collision of two proton is what? That means we need to calculate the geometrical cross section. And R0 is already described, 1.3 into 10 to the minus 13 centimeter or 1.3 femtometer, that is 10 to the minus 15 meter, whatever. This is written in CGS unit, whatever. So we need to calculate the geometrical cross section in the first question. I'll discuss it, but let me tell the let me utter the second question also, because I will solve the both question one by one after this, because we don't have much time and I am already sick today. But the second question is, mean lifetime of combustion of two protons into deuterium in the sun is. That means we need to calculate the mean lifetime in the second question. So first question we need to calculate the geometrical cross section. Then we will go to the mean lifetime that I was talking about, that try to relate with each other. Once we note the cross section, we in second question we need to calculate the sigma v to get the mean lifetime. Okay. So first question I will discuss, then second question. Now let us first, very firstly, discuss the third question, because there is nothing new about that, because you have already solved this question in your assignment 3, that more massive stars will not, which option is true, consume available nuclear fuel more rapidly, b have a higher energy production, c have a larger lifetime, d all of the above. Which one will be true? You can write the answer in the chat box, or either, as we don't have much time, I'll move forward faster. So let me answer the question, that the answer is have a larger lifetime. More massive star will not, remember, will not have a larger lifetime. We are asking more massive stars will not have a larger lifetime. Why? Because more massive stars means it has more fuel, and it is rapidly changing with the with, as it is moving towards the nuclear reaction, and it is moving towards the iron, as it has more an amount of energy, and it is fusion is happening much more rapidly. So consequently the fuel will exhaust much faster, and the lifetime will be shorter. So so that now let me go to the writing pad and discuss this question 1 and 2. Question 1 was classically the geometrical cross section for the collision of two particles, sorry, two protons. I'll go first because I have already discussed these things, and now when I solve these questions, you should connect. Or you can also try by yourself and tell me the answer by writing into the chat box, or by unmuting yourself. But I'll go fast because I have discussed all these topics very rigorously and very elaborative manner for these past 1.5 hours. So the now answer, let me solve. They ask sigma, that is equal to pi rp plus rt whole square is equal to pi r0 square, ap to the power one third plus at to the power one third whole square, that is equal to pi 1.3 into 10 to the power minus 13 centimeter square into 1 to the power one third, because this is proton, 1 to the power one third square, that will be equal to 2.1 into 10 to the power minus 25 centimeter square. All right. So this is how we'll solve. And as I am solving faster, if anyone, again I am telling, anyone wants to get these materials, please give me his or her mail id. I will give the permission to the folder that where I have given every where I am keeping every files whatever I am using for the teaching purpose. I will give the access to them, whoever will send me the mail id, because you can access whenever you want. And obviously please do check the discussion session in YouTube, because if you forget something or if you miss the class, that will be helpful for your examination purpose as well as for if as I'm going faster.
Ma'am,
Yes.
ma'am, in the week 3 assignment, there was two deuterons.
Hmm.
So whenever there will be two deuterons, then AP and AT will be 2.
AP and EK, the deuterium is yes.
Okay.
Now we'll go to the deuterium as sorry, yes.
In assignment, there was deuterons.
Yes, yes, yes. All right. And the next question is about deuterium, so your doubt will be clear. Okay. And yes, you are right also. So the next question is, so your question is Z1 is Z1 equal to 1 for PP reaction, and yes, all right. All right. So question 2 is mean lifetime of combustion of two protons into deuterium. Oh, you are asking that yes, deuterium is nothing but 1H2 and 1 is the Z and 2 is the A. Yes, you are right.
Yeah. That's why
Okay.
the question number one for
Yes, yes.
assignment 3 this year.
Okay, now it is clear now.
Yeah.
Okay, all right. In the sun is mean lifetime of combustion of two protons into deuterium in the sun is what? So there are options, but I will not write the options and waste time. I will do solve it because this is a big problem, and this type of question I think there was in the assignment also, and there are a lot of things, lot of steps need to follow to get the right answer, to reach to the right answer for it. So let us start solving this. Okay. Non-resonant reaction, this I have also discussed. Non-resonant reaction particle pair is equal to that what I have written, that is nothing but the average of sigma v. That this concept, now we are going to use this concept as well as this concept. By using these, and everything is related, you can find it while you will solve this question, and you will get that how we are connecting with each other. And as I have already discussed, I will not go to these details again because I have shown you in an elaborative manner. But let me solve the question now. That sigma v, will calculate first. That once we know the sigma v, then we need to calculate ni, that is a number density. Once we know the ni, then we need to calculate the mean lifetime is equal to 1 by ni sigma v. Okay, this is the steps that we have to follow. Step 1, step 2, step 3. But in between that, we need to follow some other things also. You can just follow the problem solution. The solution. The first thing is sigma v. Now I will write the exact expression of sigma v. Sigma v is equal to 7.20 into 10 to the power minus 19, 1 by mu z1 z2 tau square into e to the power minus tau se0 centimeter cube per second. This is the expression where tau is a constant, that is equal to 42.46 z1 square Z2 square mu by T 6 whole to the power 1/3. Now where you will get these relations? For that, let me write the difference here. That is, this is the from the book Cauldrons in the Cosmos. Please do check this book. This equation is given in chapter 4, equation 4.27, and this tau, this is given in equation 4.23 in Cauldrons in the Cosmos, that book itself. Okay, chapter 4. So this is the formula for sigma v, where there is a constant, that is tau, that is going to be very like this. AC0, that is the astrophysical S factor, nothing but a scaling factor of cross section, which is much more useful. Why? That will come after some time. So this is the astrophysical S factor. What we left with? What we left with is AC0 is done, tau is done, mu is obviously reduced mass, I am not writing, and Z1, Z2, you all know that the mass number. So Z1, Z2 E squared is a Z1, Z2 is a mass number. Okay. So now once we have that, then AC0, how it will vary? AC0 will vary like 3.8 into 10 to the power minus 22 keV B. This is written in page number 335 of the same book, Cauldrons in the Cosmos, and this is the main book for whoever is following. Then we need to calculate now the sigma v, because now we know everything. 7.20 into 10 to the power minus 19 into 1 by 0.5 into 1 into 1 into 13.665 square e to the power minus 13.665. 13.665 is, you will get if you calculate the tau here, that I am not calculating. You please do it by yourself, by your hand at home. Then 3.8 into 10 to the power minus 22 kVb. That, okay. So that is the that is what is the sigma v. Finally, you will get 1.187 into 10 to the minus 22. I have written all the values previously, so that I don't need to calculate it here and waste time in during the class. That's why I am writing so fast. But this is a long problem. You need to do step by step. Now we know the sigma v, so we need to know that the first step is done, second step is ni. We need to know ni, that is the main thing. Once we know that, then we will be able to calculate mean lifetime. So ni is equal to rho na xi by ai. Here it is nh is equal to rho na xh ah. Okay. So nh equal to 100. And one thing, whenever I solve the question, I write the units beside it also. Do check the units, because sometimes when you solving any question in any competitive exam or writing examination, then sometimes maybe you are not remembering something or doing something wrong. But if you write the units beside that, then you always can calculate the dimension and check and verify it, that if you are right or wrong, if you are doing right or wrong. And you will also get that if it is in CGS unit, in SI unit, or what. So this is a good habit to continue with. Okay. This is a Avogadro number. Then the 0.5, that is the XH, and H is equal to 1.00785 gram per mole inverse. Finally, we will get 2.9866 into 10 to the power 25 centimeter cube And if anyone wants to know that how this equation comes, then please go to page 141 of the book Cauldrons in the Cosmos. Okay, so once you have all this,
Ma'am, what is the name of the book?
name of the book is Cauldrons in the Cosmos. I am writing again, maybe to give this
Okay, and
call.
the author is?
You can search it that, because I have forgotten to write the author names here. So maybe that,
Okay,
maybe
okay.
I'll let you know. Okay, once I check, maybe in next
Okay, that
class.
means PDF file is available.
Yes, 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 yes.
Okay, Cauldrons in the Cosmos.
Yes, Cauldrons in the Cosmos.
And how we will provide our email IDs through chat box or?
Okay, let me write my email ID.
Okay, that's better.
Yeah, I am writing my email ID. Whoever find any question or anything, you can write me. Okay, I have written in the chat box. Okay. I have written in the chat box, and you can also share your mail or by writing me or writing the mail ID in the chat box, because I want to give you the whoever wants to get access of these materials, I'll give the permission, then you can see that in the Google Drive folder. Okay, so yes. So now whatever what I was discussing with the mean lifetime now. So the mean lifetime is 1 by nh sigma v is equal to 1 by 1 by put this value 2.9866 into 10 to the power 25 centimeter cube into 1.187 into 10 to the power minus 2022 centimeter cube per second. So this is the mean lifetime we calculate. If you calculate, then you will finally get it as 2.821 into 10 to the power 17 second is equal to 8.94 into 10 to the power 9 years. Do this example again and again by doing all the calculations step by step by your own. Then you will get the problem, you will get problem and you will solve again, then you will realize, and then you will be able to get the problem smoothly. Okay, so this was the second problem and very important problem for today, and the most important problem. Maybe this kind of problem you have also you also got in the assignment, and you will get in the final examination. Okay, so this was the third question. This was the second question. Third question I have already discussed that more massive stars will not have a larger lifetime. Now I will go to the question 4. That is the binding energy per nucleon of 4 helium 4. That is, the details are given, like the binding energy per nucleon of 4He that you have to calculate, and the details whichever is given for this question is this. And I have calculated binding energy in previous class several times, discussed and also calculated in elaborative manner. Wait a minute. Okay, Yes, so I have already discussed about these things in elaborate the binding energy calculation in previous class. Please go to the week 2 YouTube link, or check the discussion folder and discussion file, whatever you have with you as the notebook. They have to revisit these things. Binding energy is already discussed. I'll just go to the solution directly, not discussed in not I will not discuss again and again. So binding energy will be 2 mp plus 2 mn minus m 4he into, and I calculated this problem only in previous class. So I hope this everyone have done in their assignment 3, whatever there was in the SAM portal. Okay, so this will be 227.2740. This is again the recap. Again the again you can do. Okay, and now the thing whatever is given here is binding energy per nucleon. That is 27.2740 by 4. That is equal to 6.8185 MeV by A, and this is what we call binding energy fraction. That I have discussed, that binding fraction is equal to binding energy per nucleon, that is equal to FB. That is what is that what it want to know here in this question. So this is the question 4. Now I'll quickly go to question 5, that is that I'll not go I'll just read this, and you have already solved this, not solved, you have already get this question in SAM portal also in your assignment 3. So I hope many of you have already known, is aware of this answer, that is half lifetime of a free neutron is around, answer is 611 second. Question 6, I'll go to the
Ma'am,
yes.
all these questions are from previous assignment, previous year assignment.
All these questions mostly they are from previous year's assignment. Some of them are from this year's assignment, and some of them are from my own.
Okay, okay. And ma'am, actually, we are lagging behind 1 week. That means
Yes.
whenever the week.
That is true. That is absolutely true. I don't know how NPTEL team has arranged this, because somehow this has happened. Like this is going 1 week behind the actual assignment, whatever is going on.
Yeah, yeah. Actually, week three assignment has gone, and now we are solving week three and related topics.
Yes, yes.
So that are not helping. That is also useful, but that are not helping us directly.
Actually, they want that you guys first solve the problems, then we help you, and eventually it will finally help you in the final examination, so that we can see that how you are getting the course itself without our help. But as
Okay.
you are pointing out the point that I have already told them that, and I have already I am also with your support that yes, the
Yeah,
it
yeah,
should run with that your assignment, because otherwise
yeah,
it
yeah.
will not help you much. As if it was in previous week, then it will be much more helpful for you.
Yeah, 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 yeah. Actually, whenever you are helping us, the last date already gone.
Yes,
Okay.
maybe we
And
can prepone and
ma'am, one more.
yes,
Okay. Prepone. Yeah. Yeah.
yes, tell
And
what.
then any.
Sorry, your voice is actually breaking. Can you say again?
The
Sorry.
next there will be a Tuesday.
Sorry, I can't hear you. Please, can you please write into the chat box, or just tell again. Okay, so we were discussing question 5. You write Pinto, and in between that, let me. What are you doing? What are you doing, assignment, ma'am? Sorry, I could not get you, Meghala Susila. What you want to mention? But let me. There is not much time, so I'll go with the further topics, like see my slides, and what I was discussing question 5. Next question, binding energy question, is already been discussed. Now I'll discuss these two questions, and before that there are a lot of things to solve, and maybe today we'll not be able to complete all these. Question 6 is question 5 is telling that in question 6 I am solving the question 5 now. Okay, the mass fraction of one hydrogen 1H and 4He in the solar interior are 0.73 and 0.25 respectively. Number densities of 1H and 4H are what? This I have already been discussed, so I'll just solve directly. And first, for that, let me present the writing pad again. Question 6, it will be like not questions, it will be question 7, question 7 actually. So now I'm solving the question 5 according to the slides. So the question 5 is the mass fractions of 1H and 4He in the solar interior 0.73 and 0.25 respectively. Number densities of 1H and 4H are. Pinto is asking, every Tuesday there will be any class of yours, because sometimes there are classes on Tuesday. No, I will not take any class on Tuesday. I will take class on Saturday only. Okay, I'll take class. My classes will be on Saturday. All right. And Meghala Susila, what you want to mention? What are you doing, assignment, ma'am? That I did not get. Please write. Clear the question. That what we want to ask. I will definitely answer. Now let me go to the questions, because there is not much time. Now the mass fractions that you have already known, you had already aware about, that mass fraction is n of 1H and n of 4He. That will be equal to just the rho NaX1H by A1H by rho NaX4Ag by A4Ag. So that will be, that I have already discussed what are this formula. And Meghala is asking, ma'am, how doing assignment? I don't know, ma'am. Can anybody clear me that what she wants to actually know? I am not getting that what she wants to mention. How doing
Ma'am,
assignment?
maybe she's very difficult with doing assignments.
Okay.
So maybe she asks some suggestion from you to how to easily
Okay.
solve the problems like that, I
So,
guess.
every one of you, I just, as you mentioned, yeah, thanks Naresh Nandu, who that for clearing that. Everybody is getting the points whatever I am mentioning or not? Like,
Yes,
Yes,
ma'am.
ma'am. It's clear, ma'am.
yes, no,
Yes, ma'am.
it is
Yes, ma'am.
helpful for you.
Yes.
Yes,
Yeah,
ma'am.
yeah,
But
yeah. Obviously, it
sometimes
is helpful for
finding
us.
difficult, sometimes finding difficulty solving the problems from assignment. Now we are clearing those doubts, ma'am. It's very helpful.
Okay, that's great. But I think
Ma'am,
Meghala Susi, yes.
actually, we are having doubts,
Mm-hmm.
and we are clearing doubts on the next week, not at the ongoing week. Actually,
That's
whenever
the
the
big problem.
assignment date is, yeah, we are clearing our doubts. Obviously, we are clearing our doubts,
Mm-hmm.
but a little bit later.
Okay. Yeah, that's a huge problem. But the dates are arranged in such a manner that if I myself want to shift it, I can't. Like there are a lot of people with the collaboration a course is running because it is running in a all India manner, and we need to follow some dates, rules, all those things. Otherwise, literally, whatever you guys are mentioning, that is absolutely true. I am also thinking this thing that I am doing 1 week later. Then how will it help me? But yeah, let's see if I can do anything. But at this moment,
Uh,
after yes,
actually, there are many problems that is not cleared in the given lectures. That means which are already in the in our lectures.
assignments.
Okay, and the doubts are clearing by you.
Yes, yes. Like the
And if
I found that the
we are being
luminosity, the
late, then
mathematical
it is
backgrounds are not
we
there
are
in
facing
the
difficulty.
lectures. Yes,
The mathematical background is not very clear,
yes, yes. And in the lectures,
and the
the
mathematical
mathematical concepts are
background
not there.
by you.
Hmm.
Yeah, and there are many mathematical problems in the assignment.
Yes, that's true. That's true. In the lectures, they are mostly like they are totally very vague about mathematics, and that is totally dependent upon the verbal things, not mathematically involved. But assignments are mathematically involved sometimes, and they need to be discussed beforehand. And but I am trying to check the assignments as well as to check the lectures, that what is mentioned there and what is not covered here, and telling those points and covering those topics again, so that it will not be difficult for you, at least for the final examination. But in any time if you find that you are getting any trouble in solving anything, or no, you need to know further more about something, you may write to me directly via mail or in a ask a question portal. uh, if you want that some other topics also need to be covered. But I am giving the effort to get to those mathematical concepts which is not discussed in the classes, in the lectures, but given in the assignments, and some extra topics also which may be helpful for you. But if you give me the feedback, that will always be helpful for me. Okay, and there
Okay,
was
ma'am.
one.
Okay.
Yes, yes.
Yeah, yeah. No, ma'am. Okay, okay, okay,
Okay, and
okay.
there was a
That
feedback form for these sessions also. I hope every one of you have submitted. That will also help us.
Yeah, sure, ma'am. Okay, ma'am.
Okay. So yes. So Meghala Susila, I just want to mention that if you are finding problem, please discuss among yourselves, your friends, whoever are there. Find their mail ID, because your friends can discuss more than us, and you can ask any question with them and discuss them that how they are solving by writing mail to them, or use the ask a question portal as much as you can. Their TAs are there, your friends are there, all of them which whoever taking this course seriously, all are there. And the next thing is that study yourself. And the fourth thing is that follow the lectures and do these assignments rigorously, and whatever I am solving in these live sessions, do
Okay,
those
ma'am.
again and again. And if you find any problem, please write by mail or ask a question portal. And I think you will find some way to get out of it. Other than that, there is no way to get out of it. But I am hopeful that everyone will be very good in examination and doing good in the assignments also. Yeah, and this class is already going very. I am liking it that you guys are interacting and writing questions. All right. So the next question, whatever we are discussing, is that what is the ratio of the mass fraction? So mass fractions of these are given, and number densities of 1h and 4h is what. So this is just the same thing, and if you solve this, then you will get 0.73 by 1.007825 into 4.002603 by 0.25 equal to 11.16 by 1, that is equal to 11.6. Do the calculations by yourself again. And next question is given for supernova events. Question 6, for supernova events where T6 equal to 5000, calculate the most probable energy of particles. Most probable energy is nothing but KT, K, KBT, that is equal to 8.62 into 10 to the power minus 8 keV K inverse into 5000 into 10 to the 6 Kelvin equal to 431 keV. So that was the next question, and now the option is 431 means option E. Now the half-life of a free electron, that is already discussed. Now the next question is question 8, that is for the stellar temperature of T9 equal to 0.01, number of particles with an energy is equal to 550 kiloelectron volt compared with those with equal to 0.86 kiloelectron volt is in the ratio. What is the ratio? Now they are asking number of particles, how they are varying. Question 8. Number of particles. Now in case of these, it depends upon energy, and how that depends, that phi E is proportional to E into the power minus E by kBT. So if you number of particles, now here it is asking for the stellar temperature 0.01, number of particles with an energy these compared with those in E equal to 0.86. That means we need to find out phi at 550 keV by phi at 0.86 keV is proportional to, just find that 550 8.6 into 10 to the minus 8 into 10 to the power 7 by 0.86 keV to the power minus 0.86 by 8.6 into 10 to the power minus 8 into 10 to the power 7. So it will be equal to 3.12 into 10 to the power minus 75. Please calculate by yourself, as I don't have much time, so I am going very fast, and I am sorry for that reason. And now the question 9. Question 9 is astrophysical S factor is more useful than cross section because it contains all the strictly nuclear effects. Option B, it varies smoothly with beam energy for non-resonant reaction. Option C, it is easy to calculate. And option D, none of the above. So the question is, astrophysical S factor is more useful than cross section because of what? So what is the astrophysical S factor? I wanted to discuss about it a bit, but today I don't have time. So just remember the answer is at this moment B. It varies smoothly with energy for non-resonant reaction. And how is that? I'll discuss in next class. What is the astrophysical S factor? So answer is B for this question 9. But I'll discuss astrophysical next class. Next class I'll discuss first the astrophysical S factor. Now the question 10 is, what is the spin parity of 43 calcium nucleus in the ground state according to the cell model? I have discussed in very detailed manner how will you get the ground state. Please calculate it by yourself. This is your homework.
Okay, ma'am. Doing.
And for C, Z is equal to 20 and N equal to 23. I am giving you some time. Please try at this moment. If you are not getting, I'll not tell the answer. I'll start the class next week by discuss from this.
Okay, ma'am. Thank you, ma'am.
Okay. So next week, and I let me give you some more extra thing that you can try to solve at home. That is homework. Homework. That is question. Find the ground states for 13N7, 11B5, 43CA is already written here. Do these three and let me know the answer uh, on next week. I'll start at 5 p.m. and first by asking these that everyone has solved or not, and then I'll solve this how to
Ma'am,
get the yes. Yes.
when this lecture will be uploaded on YouTube?
And mostly it is uploaded in today only at night, but today particularly for today I can't give you assurance that I can upload it by I mean they can upload it by today because of some reason, but within tomorrow definitely you will get by Sunday morning.
Ma'am,
Oh,
Yes.
okay.
ma'am, I have written my mail ID in the chat box. Can you kindly give access
Okay.
to the previous?
What is the mail ID of your Saranya Majumdar? I
Yes.
have given, I think.
Okay, ma'am. Thank you, ma'am.
Okay, let me check once. Sharanya. Yes, I have given. Okay. Uh, Now, what was that? Where will the lectures be uploaded? Okay, let me give you the link again, and you guys can give the notification on. You will. For that, as you are asking that for the YouTube links, do subscribe then this channel, then you will get the notification automatically when it will be uploaded. Then you don't need to check that if it is uploaded or not. Okay. In that make sure that the notification is on, then you will get automatically the notification that if it is coming, if it is uploaded or not. So do these homeworks that for 43 CA 20 13 and 7 11 B5. I'll start next class by asking that if you got the ground state of by using the cell model or not. And I also wanted to discuss about the astrophysical S factor and photo disintegration, but today time did not permit. But we have discussed a lot of things today. But so the next thing is that let me end up this class but just by noting down that what will be discussed in next class. First thing is
Ma'am, next class will be from also 5 p.m.
yes, 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 5 p.m.
Ma'am, ma'am, one thing, yeah, it can be from 6 p.m.
No, actually it cannot be changed.
Okay.
Please try to join at 5 p.m. But if you have a problem that some classes are there, then you either you manage it or you can check it in YouTube. uh, or maybe I can discuss this cell model question if you want to answer it then at last also, when you will join again. I hope everybody will stay up to that time. And but I can't shift the timing. Now the next thing is what I need to do is the cell model questions. Is that all right, Pinto?
Yeah, ma'am. Yeah.
Okay. And shell model questions, then question 3, then the third thing. Today I also wanted to discuss about quantum tunneling, but this is getting delayed now. Every time I am over time. So this is quantum tunneling that I will discuss next class for sure. And somebody is writing, ma'am, I have one doubt. Registration of exam April 29. I have a university exam. So what I do, ma'am? Okay, that is this NPTEL examination will never, the date will never change, because they have decided it before a year, and they are conducting it all over the India, so it can't be changed. And your university examination, I think they will also not listen. So you find that what is the time slot you are choosing. There are two time slots. In afternoon session, I think university examination will not be there. Either university examination will be in morning session or evening session. So you can give one of the examination in morning session and one of the examination in evening session. That is the most easy solution for you.
Oh, but whenever we are registering, there is no option for evening or afternoon. Just only date.
Okay.
There is no choice of time slot, morning or evening.
But as far as I know, there are time slots, several time slots.
Yeah, yeah. There are two time slots, but they are not giving us the option.
Oh, they decide directly deciding directly decide it, or
Yeah, I think that's so, because there was no option when I was registering for the exam.
okay, that's strange. Okay, I'll talk about this also with them, that what is the thing, but maybe
Yeah,
that.
ma'am. Yeah, that's a good point, ma'am. Please discuss about why they are not giving the freedom of choosing the time slot
Okay.
for evening or morning.
Okay. That should be given, because that is the student's choice, right? Because someone may
Yeah,
have some other examination or something else.
yeah.
Okay, I will tell. And okay, by the time, but this that is strange actually. They should give, and I don't know why this happened. Okay, let me see. And so now these three topics I'll cover up in next week, and other in the continuation of that, maybe I'll show some of modeling of star, and there will be the new topics of week 4, and we will continue again our discussion. And on next Saturday, the week 4. And today let's wrap up here. Okay, I hope everybody has enjoyed and enjoying the course. And if you have any question, doubt, please write. And please check the YouTube videos again and again, do the solve problems again and again. It will definitely be good.
Okay, ma'am.
Okay,
Okay,
bye
ma'am.
bye.
Okay, bye. Good. Thank you,
Bye.
ma'am.
Thank you, ma'am.
Thank you, ma'am.